Just a quick little video on greatest common divisor and least common multiple. Usually we write greatest common divisor as GCD and the least common multiple is LCM. You might see some people call it the greatest common factor instead of greatest common divisor, so you might see GCF instead of GCD, but predominantly it is GCD that's used. And what it is in its name. Let's start with the greatest common divisor. So it's a divisor, and it's going to be a divisor that's common between two numbers, and it's the biggest one that is common between two numbers. So that's the greatest common divisor. And let's talk about this formally. We say that a number C in the natural numbers, so we're talking about positive integers, we say it's the greatest common divisor of two integers A and B, if and only if C is the greatest natural number such that C is a factor of A, or you could say C divides A and C divides B. The least common multiple is similar. I'll write this in blue because the definition is almost identical except a few things change around. Well, the least common multiple, rather than being the greatest such that C divides A and C divides B, it's going to be the smallest such that A is a factor of C and B is a factor of C. So it's the least common multiple. So the least common multiple of two integers, if C is the smallest natural number such that A is a factor of C and B is a factor of C. Now we're going to talk about these concepts in depth in the next two sections, 38 and 39. But for now, let's just do a couple of simple examples just to make sure that we understand what these concepts are. So let's find the greatest common divisor of, let's say, negative 18 and 32. And let's find the least common multiple of negative 18 and 32 as well. So, to do this kind of with brute force, without doing any kind of clever tricks, we just need to think about what the divisors are for the greatest common divisor and what the multiples are for the least common multiple. So let's do the GCD first. Let's list all of the positive factors of 18 and 32. So for the GCD, so let's list the factors or divisors of 18. Well, they are, of course, 1 and 18 and 2 and 9 and 3 and 6. And that is it. 1 times 18, 2 times 9, 3 times 6. They are all the factors of 18. And all the factors of 32. And I should write this as, negative 18. And we're looking for the positive factors. Let me be a little more careful here. The positive factors of negative 18. And we need the positive factors of 32. So 1 times 32. 2 times 16. 4 times 8. And that's all of them. And we're looking for the greatest factor that's common to both. So looking at this, you can just see that the greatest common factor is indeed 2. It's common to both of them. And 3, 6, 9, and 18, I'm missing a comma here, they're not factors of 32. So the greatest one that's in common to both of them is 2. So we can say the greatest common divisor equals 2. And for the least common multiple, we're going to have to list positive multiples of negative 18, and 32. So we have negative 1 times negative 18 is 18. And I'll just say, rather than negative 1 times negative 18 and negative 2 times negative 18, I'll assume that both negatives cancel. So I'll just say 1 times 18, 2 times 18, etc. So let's write down our multiples here. Multiples of 18. So we have 18, 36, 54, 72, 90, 108, 126. Let's do one more. 144. And let's stop there. Let's see if we can find a common multiple in those. Let's list the positive multiples of 32. 1 times 32 is 32. 2 times 32 is 64. 3 times 32 is 96. 4 times 32 is 128. And we might as well have a look here. Do we see any common factors? We don't. So the next one would be 160. I'll list a couple more here. 192. 32 times 7 is 224. 32 times 8 is 256. So let's do the same thing with 18. Let's have some more factors. So 18 times 9 is 162. 18 times 10 is 180. 18 times 11 is 198. 18 times 12 is, I'll just go up here, 216. 18 times 13 is 234. 18 times 14 is 252. And you can see this is taking a while. And let's keep going here. So we have the next one is 270. And the next one is 288. Let's stop there. And in fact, if we have 32 times 9, we also get 288. Oh, finally, we found one. So this is indeed the least common multiple of 32 and 18. 288. So the idea is quite simple, of course, to find greatest common divisor and least common multiples. But you can see sometimes, especially for larger numbers, you can imagine this process being an absolute slog. So we want to come up with nice ways of thinking about greatest common divisors and least common multiples to help us with this. So that's what we're going to go over in the next few sections in topics 38 and 39. And we're going to start talking a little bit more about divisibility properties of numbers. The greatest common divisor comes up quite a bit in those, so that's going to be very important. But we get to learn some really cool facts. And the one that we're kind of working towards, let me scroll to make a little more room here, if I can. There we go. The fact that we're working towards is very, very important. It's called the fundamental theorem of arithmetic. And it has to do with how numbers factor. And I just want to talk about this very quickly because we're going to go into, that should be an E, because we're going to go into detail about why this is true later on in the topic 39. But it says that any positive integer greater than or equal to 2 can be expressed as a product of primes. So that's kind of neat, but the other neat thing is that it's always unique. There's only one way to do it, up to order. You can rearrange the order of the primes, but multiplication is commutative anyway, so it doesn't really matter. So we'll just say up to order. And that is a very, very fundamental and cool fact. And that's kind of what we're working towards in these next two topics.